I have three imaginary square blocks of chocolate. Now we have two opinions. Either you can select two smaller blocks or just the one larger box. If you were trying to get the most amount of chocolate, which would you pick before we made this description? Let's see what we can find out under this particular box of chocolate. Each of these blocks is a square of the sides have the same length and the angles are all right angles. And these lines here are straight and perpendicular, so the angle must be 90 degrees. That means the space in between the blocks is a right angle triangle. Does this help us find out whether the area of the two smaller blocks is bigger, small, or the same size as the largest block? Let's do the experiment. We will try making a right angle of our own and creating a square from the length of each side. Here I have drawn a right angle triangle, and when I measure the side, they are 8.3 centimeter, 14.5 centimeter, 16.2 centimeter. If I use this side to make the square, then the area of the first square will be 8.3 times 8.3, or about 69 centimeters square. The area of the second square will be 14.5 times 14.5, or about 210 centimeters square. The area of the third square will be 16.7 times 16.7, which is 279 centimeters square. So for this example, which box would I pick? Well, these two small blocks together have an area of 210 plus 69, which is 279 square centimeter. That's the same as the area of the largest square. So for the example, it wouldn't matter whether I pick the two smallest square or the largest one. Since they both the same area, but does this work for all the right angle triangle, and how can we show this? This is turned out that for every right and good triangle, the square of the length of the largest side is equal to the sum of the squares of the two small shorter side. We can write this fact out using symbol. If we label the largest side, the hypotenuse is C, and the two shortest side as A and B. So if the first side length is A, then the area of the square will be A times A, or A square. The second square will be B times B, or B squared, and the area of the largest square will be C times C, or C squared. So for any right triangle, C squared is equal to A squared plus A squared. This is called Pythagorea's theorem. So if we turn over each of these blocks, we can count the number of bases that are on each square. The smallest square the smallest square here is 6 times 6 square, so it has 36 bases. Second box is 8 times 8, so it has 64 pieces. And the biggest blocks is 10 times 10, so it has 100 pieces. Now, if you choose the two smallest square, we would end up with 36 pieces plus 64 pieces, which is 100. That is the same number of the pieces as are in the largest block. So whether we choose the two smallest square or the one largest square, we would end up with same amount of chocolate, and that is exactly what a Pythagorean theorem tells us to accept. Thank you. I have three imaginary square blocks of chocolate. Now we have two opinions. Either you can select two smaller blocks or just the one larger box. If you were trying to get the most amount of chocolate, which would you pick before we made this description? Let's see what we can find out other this particular box of chocolate. Each of these blocks is a square of the sides have the same length and the angles are all right angles. And these lines here are straight and perpendicular, so the angle must be 90 degrees. That means the space in between the blocks is a right angle triangle. Does this help us find out whether the area of the two smaller blocks is bigger, small, or the same size as the largest block?